Okay, now we go. You're insulated, it won't hurt you. Much.
Hello guys, in this video I would like to discuss how I am planning to create a Vandergraff generator by ourselves. If you look at my demonstration over there, I create a spark using static electricity built on my body using a Vandergraff generator. But the point is, I and my students are working as consumers. Now it's time for us to move and be creators and create our own equipment, which we start with the Vandergraff generator. First thing, in my class, I will explain them why static electricity is important, where we are using it, like photocopiers or even lightning is because of static electricity. So my objectives for the class will be the students should be able to understand main parts of Vandergraff generator, and they should be able to explain the physics of electrostatics, and ultimately they should each three students in one group, each team should create their own functioning Vandergraff generator. So the timeline will be 10th Friday and 17th and 24th Friday. The first one they will do research, and I will explain the basic parts of Vandergraff generator and how it works, and then they do the research and they decide their own design plan. And 17th, once they purchase this, before they purchase equipment, I will do a risk analysis, because this involves high voltages and electric shock is possible. So on 24th they will make their presentations, and they will demonstrate how they are each of their equipment work to the class. So main part of a Vandergraff generator, it's a transformer, and it needs a DC motor and AC to DC converter, and as assembling these things and creating a Vandergraff generator is what we expect from the students. But differentiation strategies, the students have flexibility of choosing their team members, and they can, if they are not very sure about their skills, they can use adapters and transformers, pre-made ones, and then their job is only to assemble the Vandergraff generator. Or the more confident students can start from zero, ground level, and they can create transformers, they can create adapters, and then they can assemble and create the Vandergraff generator. These are my strategies for uh, differentiation, and these are the resources, and I'll be sharing these references with the students, because they need to go through YouTube and other resources to watch how to create a Vandergraff generator. I want students to make a Vandergraff generator, by their own method. It needs voltage to go to low voltage, because this is 12 volt, right?
Yes.
And it has to convert to AC to DC.
Yes.
And we need a motor. Come here. We need a motor, and we need by changing the resistance you can increase or decrease current, and we need a metal door. These are the things. So I will show them the transformer. Why do we use this? To change the voltage, right?
Yes, and the voltage.
From higher to lower. I think this one is.
Yeah.
This one doesn't work. Sorry, yeah. And I will show them how DC motor works. This is not AC, this is DC. This is AC, right? Yeah. So this is a DC motor for them to, yeah, this is a DC motor. I'll give them a DC motor so they know how motors work. And yeah, good. So yeah, what do you think? We give this one, and they have to make a AC to DC conversion, and they have to make a variable resistor, they have to make a transformer, and they have to make this Vandergraff generator.
It's more of a community than it is just a machine shop.
Creative problem solving is a skill that we want our kids to have. And the Makerspace is the place in the classroom where we're cultivating that skill in our kids.
I'm supposed to make something, and it's like supposed to help people or like help fix a solution.
Overall, how Makerspace makes a difference in our classrooms. First, we have to understand Makerspace is a long-term investment. It's a paradigm shift as a school or as a section rather than one or two activities. So, second, the Makerspace has the potential to completely transform teaching and learning. How do we teach? If you think, first we teach facts, then they remember, the students remember the facts, then they understand the concepts, then they develop into, some of them develop into higher level of creating and synthesis in Bloom's taxonomy. But here it's the other way around. They have a problem, they have a situation that they want to tackle. So they go back and find the knowledge, and then they create things for to answer that question. So the students are mostly in this makerspace situation. They are always dealing with the higher level learning, which is dealing with creation and synthesis rather than remembering and recalling facts, understanding facts. And third one, why makerspace is different and important is the design starts with the problem or an issue, not with facts. So as it starts with the problem, the students' understanding and the way of learning is completely transformed because the students learn by doing things rather than listening to the teacher. So I think this is a very, very important tool in our teaching pedagogy, and I'm definitely looking forward to next week Friday, this Friday, to see how it goes. Thank you very much.